Hi, Gil from Testing Gil here. Flaky tests, the bane of my existence. Well, that and reaching my token limit. When I started unit testing, there was no such thing as a flaky test. A test would pass for the right reason and it would fail for the right reason. Naturally, with other kinds of tests, that's not always true. API tests can fail for the wrong reason. And hey, if you want to see a magic trick, run it again. We don't like flaky tests. We spend a lot of time debugging until we get to the root of the problem, which is often not reproducible. So we run it again for a couple more times until we see green, and then we'll say, we'll investigate it the next time it happens. Right. It's like hearing a sound while you're driving your car, and instead of just stopping and looking under the hood, you just say to yourself, it will just go away. Is it possible to get rid of flakiness? Well, you can definitely reduce the number of flaky tests, but we can't kill them off completely. Flakiness is related to our understanding of the system. You see, we write tests in a way we believe the system should behave, but it's more about the believing than really understanding. And this is where we breed our assumptions, which are the bane of my existence. Also, you see, we write tests assuming that the system is in a certain state. And we make an assumption that this initial state will always be there when the test starts to run. Sometimes we're correct, and sometimes the test fails. Here are a couple of the usual suspects that bury assumptions in our tests. Number 1. State pollution. You're testing an API that creates a user. You run it, the test passes. You run it again, the test fails. Why? Well, the test assumes that there's no user with this unique email in the system when it starts. First time you run it, the assumption is correct. But then, after we run it for the first time, there is a user with this email. So when we run the test again, the test fails. And we fall for it every time. Number 2. Dependency. You have two tests. When you run them together, they pass every time. But when you run one of them once in a while, sometimes it fails. Why? The first one checks that you can create a user. The second one checks that you can delete that user. The assumption here is that we'll always run these tests together. When we run them in this order, there will always be a user to delete. But if you run the second one on its own, surprise. Number 3. Concurrency. Let's take a look at these two tests. The first one we already know. But this time we learn from our dependency mistake. We create a user. Then we call a get API that gets the number of existing users in the system. Now, if you run the second test in isolation, everything looks fine. But if you run the two tests in parallel, it may be that the post from the first test will get in between the post and the get from the second one and will change the count of the users in the system. This will fail the test, but if you run it again, it may work. The assumption here is that this test will always run on its own. Avoiding concurrency issues is tricky because we don't think in parallel. We think and write tests sequentially, and we kind of assume that the tests will run in the same way. Number 4. External factors. This could be caching or feature flags on time of day, third-party services, or a combination of all of them. The common theme for all of these things are these are not coded in the tests themselves. However, they will impact how the tests run. Look at this test. This is a test that checks the performance speed of the response of the API. And when you run it, it passes every time. The reason it passes every time is that the code inside the API first checks if the data is in the cache, and it retrieves it from the cache and returns the response very quickly, at least until somebody else cleans the cache. Then, when our test runs again, it will look at the cache, see the data is not there, and go visit the database to look at tables, pull levers, read indexes, whatever it does, and return a response. Slowly. And guess what happens when you run it again? Everything will look fine. So, you want to reduce the number of flaky tests and spend less time on debugging? All you need to do is remember those 4 suspicious guys. And try to see if they lurk around while you're writing your tests. Are we assuming that some data exists before we run them? Do we leave something behind when they're finished? What impacts the result of the test outside the automation code? Just a few questions. Save you a bunch of time. Also coming, the API Masterclass. In this Masterclass, it's me, you, working live, hands-on, on things like planning and flaky tests and data state and other stuff as well. Check out the details below. Thanks for watching. If you like this video, like, subscribe, share it, and watch other videos on this channel. Until next time, bye-bye.